I'll leave you guys to crack on.
Great. Thank you very much. We really appreciate the opportunity to speak before you guys today and share a little bit about Massivit, our company, our technology. And my name is Kevin Sykes. I am the president for North America for Massivit. Today joining me, I've got Jürgen Weimer, and Jürgen is our sales leader for North America, and he will be sharing information about our GDP technology. We wanted to save you guys from having to listen to any one of us for an hour. So Jürgen's going to share, he's going to spend a few minutes talking about our GDP gel dispensing printing technology. And then I will follow that up with our next generation technology called Cast in Motion. And then we'll open it up for Q&A at the end. As I mentioned, I have responsibility for North America. We also have with us Cindy Gaylord. Cindy is our marketing specialist for North America. So she is the one that actually made us aware of this opportunity. And so we're very happy to be here. And again, thank you guys for allowing us to share with you. And then knowing that there are a lot of engineers on this call, we also have Bharath Lavu, who is our applications engineer. And he is one of our technical gurus, if you will. And so we expect that there will be a number of technical questions at the end, and that will be above Jürgen and my pay grade. So we thought Bharath should be here as well to be able to answer those questions for you. And then the last thing I'll say before I turn it over to Jürgen is that my counterpart in Europe has responsibility for Europe, UK, Middle East, and Africa is Gaspar Bugli. He is the general manager for the region based out of Brussels. So I anticipate that at the end of this, there will be tremendous interest for speaking with him as well and his team. And at the end, you will have all of the contact information for that office. So with that, I will turn it over to Jürgen and look forward to the session.
Thank you, Kevin, and thank you again to the audience. It's a great opportunity for us to talk to you about Massivit. And we want to talk about automated boat building with industrial 3D printers. Before we start with the presentation, I want to pause here for a few seconds for a safe harbor statement. And with that, I want to give you a quick overview of Massivit as a company. So Massivit itself was founded back in 2013. It stands for Real Disruptive Technology, simply because our 3D printing technology is 30 times faster than any other 3D printing technology out there in the market. We got hundreds of systems installed around the globe, and the company went through a very successful IPO back in February 2021 and is traded on the Tel Aviv stock market. We are focused on manufacturing industries, including automotive, marine, railway, and many, many other industries. We can really help our customers or industries to be cost effective in the production of large parts, molds, and prototypes. These are two great pictures and examples we're going to talk about on the following slides. Those are actually two big projects done by some of our clients, or exactly by two of our clients around the globe. So like I said, we're going to talk more in detail about those two projects. Why 3D printing? In general, 3D printing disrupts many different industries simply because it enables industries to be more cost effective, more time oriented within their production processes. If it is like in the automotive industry or consumer products, decoration and jewelry is even a great market for 3D printing. And as many of you might know and be aware, health and medicine is already a huge industry for 3D printing. But 3D printing is always or was limited to three main barriers in the past. So Massivit's target was right from the beginning to overcome those three challenges or barriers. One is definitely speed, the other one is size, and the next one is materials. Massivit came up with a technology that enables 3D printing to print one really, really large and really big, and on the other side, very cost effective and also very fast. So Massivit basically created a new league in large scale 3D printing within the industry. I want to talk about Massivit's portfolio real quick. Massivit's portfolio is separated in two different generations. Our Gen 1 is called Gel Dispensing Printing, or as we like to call it, GDP. And our Gen 2 is called Cast in Motion, or SIM as we like to call it. GDP is available on our technology platforms, the 1800 and the 5000 series. The 1800 as a base model comes with one printhead. It can print three different resolutions, meaning layer heights of 0.8 millimeter, 1.0, and 1.3. The Massivit 1800 Pro series is available with either one printhead or with two printheads. So with two printheads, you can actually print two separate and completely different parts at the same time. One on the left side and one on the right side. The main difference between the Pro series and the 1800 base model is we got a variable resolution in the Pro series, meaning we can change the layer height within an object while we are printing. To give you a quick example, if you want to print a full-scale mannequin, you could start at the feet with a layer height of 1.0 millimeter, and as soon as you get up to the head, where you want to show more details in the face around the mouth, nose, and ears, for example, you could switch then to a layer height of 0.8 millimeter, which will give you definitely more detail. Our newest platform, if it comes to GDP printing, is our Massivit 5000. It comes already with two printheads. It has, in addition to the three resolutions we got available on the 1800 Pro series, two new resolutions. A final layer height of 0.5 millimeter, which will give you much more detail, and another layer height of 1.5 millimeter, just in case you want to speed up your printing processes. Of course, the finer you print, the more time it's going to take to finish a part. Then we got the 5000 Max, which basically can print in addition to our standard materials with a water breakable material. The water breakable material can be used for producing sacrificial molds, for example, or layup tools for your carbon fiber or Kevlar or fiberglass parts. Generation 2 is our cast in motion technology, available on the 10,000 or 10,000G platforms. Kevin Sykes is going to talk more about our cast in motion. The thing I want to mention here right now is that the 10,000 was specifically created and designed to print and build molds for large scale parts, tools, jigs, and fixtures. And again, Kevin's going to talk more about this. On the GDP side, we got different materials available. So all our materials are based on an acrylic-based photopolymeric gel. And as long as it is raw, it feels and looks like a toothpaste and has the same viscosity like a toothpaste. The material gets cured while we are printing instantly with a UV light within milliseconds. Our materials are called Diamond Gel. Diamond Gel 100 is basically a white translucent material. It's great if you want to build something that needs to be illuminated. Diamond Gel 90 is a gray and opaque material. It has the same capabilities like Diamond Gel 100, but it's just gray and opaque. So if you're building or printing something that will be primed and painted afterwards anyways, there's no need to use Diamond Gel 100 specifically, also because Diamond Gel 90 is more cost effective than Diamond Gel 100. We got a flame retardant material with our Diamond Gel 20 AFR. Then we got a translucent, almost transparent material called Diamond Gel 300. And one of our newest products that will be available within the next 2 to 3 months is called our Diamond Gel 400. That's an extra strong material. And with that, I want to introduce you to our key technology based on the Massivit 5000 Max. I think it was clear to see in the video that the build size of our machines really stands for large scale. So the build size on all our machines is 4 feet deep, 5 feet in the width, and 6 feet high. Printing speeds are up to 14 inches on the Z-axis per hour. So I want to talk about a full-size mannequin again. Just imagine you want to print or scan somebody that is exactly 6 feet high and just simply reproduce him and print him. That would only take 6 hours. Massivit stands for large-scale 3D printing, specifically attractive for boat building. Full-scale end-use parts can be produced with our products and with our materials. They need to be reinforced, of course, but that's very, very time effective compared to traditional methods of building end-usable parts. Velom Nautica is our actually first marine customer. They are based in Croatia, and they understood very early on how 3D printing can be a huge benefit for them and can improve their production times and their molding processes and the processes if it comes to customized parts and prototypes. So one quote they want us to share with you is related to custom design and geometries. Wooden molds cannot facilitate unusual designs or shapes. Now we are able to create any geometry at a click of a button. This is a great example. One of their clients wanted to have an extension for the swim deck on his yard. So in order to build the extension, there was also a need to extend the walls of the boat on the left and the right side. So Velom Nautica decided to simply 3D print both walls, reinforce them on the inside with expandable foam and with fiberglass on the outside. They installed it on the boat. Of course, they did all the priming and the finishing. And at the end, it looked like it's always been there. It almost looks like a natural part of the boat itself. Here's another message for load and durability. Vessel body parts are required to withstand a minimum load. The 3D printed parts serve as a base geometrical form. We can easily pass the required load by reinforcing parts with fiberglass, carbon fiber, or Kevlar. So there are many ways to reinforce our parts or our materials to make them end-usable parts. Custom radar masts are another great example. As many of you might know, or I'm sure many of you know better than we do, is if you want to build something or a custom part, or in this case, a custom radar mast, in many cases, it needs to be built or made out of stainless steel, which will limit you in many cases with design and custom shapes, or to make it look like it goes with the natural design of a boat or a yard. With 3D printing, you can simply create a design or a mast and print it. On the left side, you see the white radar mast was printed on a Massivit system using the GDP technology. And right next to it, the gray part, is a radar mast produced with the traditional method. On the right picture, The radar mast that was printed was reinforced with fiberglass on the outside. Another great benefit of GDP is that we can print totally hollow without any infill or internal support structure needed. So for Velam Nautica, it was easy to understand and actually important to understand that they can install all the electronics and the cables on the inside of the radar mast. The radar mast was finished and painted and actually installed on the boat of the owner. Radar mast number 2 is just another example for a different design to create a custom radar mast for a client or for a boat. And that radar mast only took 2 hours to print and just consumed 2 kilos of material. The funny thing is, while Velam Nautica was producing this mast, another client walked through the shop, saw that mast, and he instantly wanted to have a custom radar mast created for his yacht as well. The only requirement he had was a slight change on the radar mast itself. He wanted to have an extra pole on top of it to install a navigation light. So the only thing Velam Nautica had to do, they had to go back to the 3D design software, add that pole on top of the radar mast, and they just simply reprinted it again in just 2 hours. The mast was reinforced with fiberglass again, painted, and installed on the boat. Here one more message from Velam Nautica. Speeds freed up resources. We use our Massivit 3D printer to produce molds within a few hours that would usually take 2 team members a few days to produce using wooden panels. This frees up our workers to work on other projects at the same time. Like in this case, a yacht owner wanted to have a bowsprit that could serve as a step for people to get on and off his boat. So Velam Nautica simply printed the bowsprit. Of course, they took all the necessary measurements before they printed the bowsprit. They created it in a 3D design software, reinforced it by using different materials, did all the finishing and installed it on the boat itself. And that was printed in just 3 hours. The traditional way, they would have to build a mold first, which would utilizing at least 2 team members and would have taken at least 14 hours to just produce the mold. So after building the mold, they would still have to go through the process of laying up material and building the actual part. That's a huge time saver right there. Another application GDP can be used for is to build molds with it. Like in this case, a customer wanted to have an extra sun protection on his yacht. So what Velam Nautica did here, and it's easy to see on picture B, is they printed a large-scale mold, actually in 2 pieces, attached it together, and then it was used as a layup tool. And again, they used different materials like fiberglass, for example, or Kevlar to build that sun roof extension. It was polished, painted, and installed, and ready to go. Another client was a little bit unlucky when he went out on sea. He actually lost his exhaust cover. So he came back talking to Velam Nautica and was hoping that they could help him to recreate a new exhaust cover. What they did, they just used a 3D scanner to scan the other exhaust cover that was still existing. They mirrored it in their 3D design software and simply printed it, reinforced it again, installed it on the yacht, and the owner was good to go. This is just a great example for large-scale molds. It is very easy simply because of the build size we offer in our systems to create full-scale and large-scale molds. On the left side, you see the original mold. On picture B, they actually figured out doing the molding process or doing the process of building the mold itself that they needed some extra room in the final part. So they simply printed an extension to make the mold a bit bigger. That extension was added to the existing mold and it was finished, and then it was good to go and to be used as one large-scale mold. Custom ergonomic dashboards. That's another huge market Velonautica just dove in real quick. You can simply print a dashboard, reinforce it with expandable foam on the inside, with fiberglass on the outside, for example, install all the electronics and make it work on a boat as an actual part. Generating businesses. Most of our businesses involve repairs for vessels. However, often when a customer approaches us for a repair, they see the workmanship possibilities enabled by our large format Massivit 3D printer and then end up requesting additional unrelated custom built parts for their specific needs. Like in this case, an air vent diffuser that had to fit an existing hole in a boat. They took the measurements, created a design in their 3D design software, printed the air duct or the vent diffuser, reinforced it, and installed it on the boat. We shared a lot of applications with you, and now we want to look at how GDP really works. So on the left side, you can see our printhead or our dispenser. On the top of our dispenser, we got a gel dispenser screw that transports or forces the material into our dispenser. On the bottom of the dispenser, you can see our printing nozzle or printing tip that is responsible for the wall thickness or the layer height. And right next to the tip, you can see a UV light. So we are curing our material instantly while we are printing with UV light. That enables us to print really, really fast, large scale, and again, without any internal support or support structure needed. Now we want to hear what the owner of Velonautica has to say about their experience with Massivit.
First time I came across a Massivit 3D printer, it really shocked me with the speed it can print and the simplicity and precision it printed.
Velonautica is based in Croatia, where there are many marinas and there are boats and ships from all over the world. We are manufacturing all types of parts for ships and shipping companies for all over Europe. We are exclusive partners for Janot, Hanse and Croatian regulation authorities. We have many large projects. We were looking for something that will speed up the time and the projects, and that's why we bought 3D printer. The main challenges in the marine manufacture is time, supplies and labor cost.
Until now, marine manufacturers lost a lot of time and money producing molds. A lot of material was wasted.
Because in traditional way we need more materials to build it, and then we have waste.
With traditional methods, we needed around a week and a half to produce mold for a mast, but with the Massivit 3D printer we need around 8 hours to print it.
And in Massivit 3 we need only one man to do it, and in traditional way we need 5 or 10 men. And while the printer is operating, other workers can work on the other projects. We save time.
In the marine industry, achieving symmetry was complicated. Clients usually come with different ideas, which are sometimes complicated to produce. With the printer, we can achieve it really precise and easy. 3D printing allows us to produce symmetric and precise models every single time. Marine manufacturers have to a degree a fear of new technologies, but with the newest developments of additive manufacturing, it becomes really easy and even necessary to use new methods. There is nothing that comes even close to the size and the speed which with Massivit can produce new parts.
So I think we talked a lot about applications in the marine industry, and of course, our GDP can be used for many different applications in industries as well. And we just want to share a few of them with you real quick. So Massivit is also focused on industries like automotive, rail, the aerospace industry, energy, and scenic fabrication, for example. This is a great project, and if you remember, that was one of the first slides I shared with you where I saw those two projects. Alstom is actually a big European train manufacturer. One of the challenges in the past was for this tram that the front panel got cracked and damaged very often. So they had to have hundreds of those panels on stock all the time, because every time a panel cracked or got damaged, they had to replace it with a new one. They decided to use Massivit's technology to simply print those panels as they are needed. So Massivit's technology helped them to reduce their stock drastically, and they just print them as they are needed. They reinforce them, they paint them, and install them on the trams. Function prototyping and mock-ups in the automotive industry. So this is a European EV manufacturer, and during their prototyping process, they were looking for a solution that allows them to print large-scale parts that are lightweight and easy to replace. Because during their prototyping process, it was required, or it is required, to change parts quick and easy many times. Because of Massivit's large-scale build size within their systems, it is even possible to print a full-scale concept car, which was done here on the right side. Prototyping, if it is a full-scale car bumper that can be printed in just 22 hours, or for example, a hood for a truck as a prototype, a core for carbon fiber jet ski, or toolless manufacturing. Fitment and prototyping, proof of design, proof of concept. This toilet was actually printed in 2 pieces in just under 21 hours. And this is actually my last slide and the last application I want to share with you before I turn over to Kevin. This is on the left side, a pattern for sand casting that was printed by using our GDP technology. On the right side, that's a final part that was pulled off a mold using vacuum thermoforming. And that mold was, of course, printed with our GDP technology. So with that, I want to hand over the presentation to Kevin Sykes, who will talk to you about our sim technology and the Massivit 10,000.
Thanks, Jürgen. I was really, when I was listening to Mike speak, I was really actually very pleased to hear him talk about that IMS is constantly looking for new ways to increase and drive productivity using technology. And that's really what we're talking about here today. And I think I need to take a second just to provide kudos to Mike for all of the content that comes out of IMS. I was actually stunned that such a small group of individuals could provide so much content and so much value for their members. Just my hat's off to you there. So we're going to talk a little bit. Jürgen talked about gel dispensing printing, and I'd like to mention here that GDP is the foundation that made what I'm going to share with you regarding the 10,000 possible. And a lot of what you heard with Bellum Nautica, the Bellum Nautica example was a lot of customized parts and the ability to do that. And that is a huge benefit for GDP, custom parts, and also prototyping and things of that nature. Well, one of the things that we thought about was, what about when you do need to make that mold and you need hundreds or thousands of parts? Well, we looked at the mold production process, and I'm sure you guys are painfully aware of it, but it's slow. It's very, very, very labor intensive. It's a dirty process. It's a lot of waste. A lot of that was discussed and mentioned in the Bellum Nautica piece. And depending on whether you create your molds internally or whether you outsource those molds, in any event, in virtually all the cases, I never say all because there are always exceptions, but generally speaking, you start with a CAD design, and whether you do it internally or you send it out, you're looking at a multi-week process. I've heard as little as 4 to 5 weeks to create a mold, especially larger molds, and but I've also heard 4 to 6 months in the case of outsourcing, because you get in line with whoever your mold maker is to do that. And then at some point you then take that mold and you create an end part. And during that entire process, there's a plug that has to be made as well. Well, what if you could just take that CAD design, press a button, and print that mold, and then finish it and have your end part? That is really what that's what the Massivit 10,000 and what we call cast in motion does. This is what we call the Massivit 10,000G. It's really 2 printers in one, and I'll talk a little bit more about that, but I'm going to just really share a bit about the technology.
The Massivit 10,000 automates tooling for composite manufacturing. This cutting-edge additive manufacturing system enables direct casting with high-performance materials to dramatically speed up tooling. Introducing the world's first isotropic 3D printed mold. The Massivit 10,000 empowers composite material manufacturers to produce custom molds, tools, mandrels, plugs, jigs, and fixtures within a matter of days instead of weeks. The Massivit 10,000 shortens your mold production workflow from 19 steps down to 4 simple steps and eliminates the need for a plug. So how does it work? The Massivit 10,000 utilizes a dual head system to directly print and cast molds. Based on an initial CAD design, the first head 3D prints an outer sacrificial shell at high speed. The second head intermittently casts a thermoset material into that shell as it builds. The shell is comprised of 2 thin walls made of water-breakable photopolymer material that polymerizes instantly under ultraviolet light. The thermoset material forms a solid, isotropic mold. The mold can then be post-cured in an oven to improve its mechanical properties at elevated temperatures. It is then simply immersed in a bath of plain water, causing the shell to crumble away. The Massivit 10,000 offers near-net shape casting. The mold can be post-finished manually or machined as needed. Your high-temp, high-performance isotropic mold is now ready for use, within less than a week. Benefit from advanced casting materials that ensure consistent mechanical and thermal properties across all axes. Discover digital tooling for a wide range of industries including maritime, automotive, rail, defense, aerospace, sporting goods, and bathware. Join the digital revolution with the award-winning Massivit 10,000 additive tooling system, offering automated, high-speed tooling for composite manufacturing.
So we are trying to help everybody achieve the extraordinary. So you heard the 19 steps to create a traditional mold. And there's a lot of waste and a lot of labor in that step, in those steps. We've basically taken those steps, cut them down to 4. 2 of them are existing steps within the 19, and then we added 2 steps. And that's where we come to 4. And I'll talk about that in greater detail. So those steps are printing the mold, as you saw there. You then take the finished printed mold and you put it in an oven. And really what that does is it allows us to bring, it's a heated chamber on the printer, but putting it in the oven allows the mold to come up to its full material properties. It's typically a 24-hour process, unattended, of course, unless someone wants to stand inside a multi-100-degree oven, and I don't think that's something that anyone wants to do. And then there is you take that mold after it comes out of the oven and you put it into a bath. During that process, another 24-hour process, the shell material that was mentioned there breaks into very, very small flakes, and then you're left with the finished mold. It's important to note here that it doesn't contaminate the water. So this is plain water, and the flakes fall into part. They are inert, and so once those flakes fall off, you can just scoop those flakes, and put them into a normal trash can and dispose of them like you would do your normal trash. So it's also a very environmentally friendly process, something that is sustainable and allows you to have a very clean process. And then that last step is to whatever you need to do to get to your finished product. In some cases, that will need very exact tolerances, and so we finish at a near net shape, so you can CNC it to the exact tolerance that you need. But that's a fraction of the time that for the entire process, or in many cases, it can be hand finished to what you need. So you've got the shell material that is created, that is printed. That is basically a GDP process. Instead of the materials that you saw during Jürgen's presentation, it is basically a water breakable material that's printed. And then you have the cast in motion. You have the casting head that then casts the material inside. It's important to note here we're casting an epoxy to make a mold, but once you have a composite material, there's really nothing limiting you to doing an epoxy mold. We've taken sawdust, mixed it with a binder, and we've cast a wood material that creates essentially a customized wood product. We've done it with aluminum. We've done it with other as a proof of concept. And so in terms of, it's not an announcement, but it just let your mind flow for a minute in terms of the possibilities. So here you've got step 1, you've got step 2. and those happen at incredible speeds. It gives you the opportunity. In the case of marine, generally speaking, in the manufacturing process, where boat builders make their money is based on the size. So they can spend their time on the hulls of boats and the much larger parts with the manual processes, and then they can take these what we call large, what they would call small molds, and they can then use those, let those take place in an automated fashion and use that labor on the more profitable areas of the business. So you've got the sacrificial pattern, the casting, the two together provide you with extremely efficient digital tooling that minimizes the amount of waste that is produced. So now let's talk about different applications. So you don't just print molds, and I talked about two printers in one. And as I go through these, you'll understand more about what I mean there. So first, of course, are traditional molds. So this example is taking the process that we just have gone through and created a mold for a motorcycle fairing. And that mold, once finished, you can do carbon fiber layup on that mold, and you end up with a very nice, beautiful part at the end, and you can make as many parts as you want. So instead of a one-time custom part, you print multiple parts. Here is a race car seat. Notice here that the tooling is built in as well. Since you've got a CAD 3D drawing, there's no need to separate, and that's, those 19 steps. Part of that is creating the plug, part of that's creating the tooling, and part of that is creating the actual mold. Now what we can do is we put all of that into one. Build the tooling into your CAD design, print the mold along with the tooling, finish it, and then pull your part off. So this entire this seat was printed in 42 hours. Add a day for the oven, add a day for the bath, and then let's say another day for this seat. Wouldn't take quite that long, but for purposes here, let's say another day. In 5 days, you've got parts that you can pull parts off of a mold. That's unheard of today. Here is just another example. You can see where the surface and the legs were printed in one piece, and so you don't have to connect ribs after the fact. And in this particular case, it helped with the air and heat transition, but it also minimizes the amount of material that's used, and of course speeds up the process. Here you've got a hydrofoil skin on a catamaran for racing. Same scenario. You've got a much larger mold here. Again, a small mold for boating purposes, but a large mold by any other standard. And you've got the hatch that's printed here and used. This is from Marine Concepts, one of our customers, who's utilizing the technologies here in the U.S. We've got Lance is the owner of a company called Lyons Industries. I'm going to share a video from him here shortly, but it's for him, automation is what's going to keep him in business. And I think Mike said it best. He said, if you're not innovating, you're gonna go away. And so this is exactly what Lance was trying to do. And so now he uses the Massivit 10,000 to create his molds. He also creates fixtures with it, and then pulls, in this case, thermoform pieces off of for his tub and shower enclosures. And so this is comments from him.
My first impression of the Massivit 10,000 and its cast in motion process was, wow, somebody finally figured it out. We can make a mold out of epoxy. Hi, my name is Lance Lyons. I'm president of Lyons Industries. We've been in business for over 55 years. We manufacture bathtubs and showers and wall surrounds. We make over 1,100 pieces a day. We run 5 days a week. Before receiving the Massivit 10,000, we made molds the old-fashioned way, which is off of a pattern.
It's a labor-intensive process. We start with a CNC routing process that gives us what we call the pattern or plug or master. And then it's a manual mold making process. We make composite molds. It's a fiberglass, resin, catalyst, filler mix.
We have to separate the pattern away from the mold and do finish work on the mold. All in all, you're looking at about 12 weeks.
So without adequate skilled employees, then that becomes very difficult to do.
Now with the Massivit 10,000, we take a design, the same design that would go to the pattern, but now we feed it into the Massivit computer and it prints the mold. We don't have to do any pattern work. We do have some finishing work to do afterwards, but it's a fraction of the time and energy and cost that it was before. For Lyons Industries, automation is everything for us to be able to grow. And we think the Massivit 10,000 fits in perfectly. It gets us to market much faster, it makes our support fixtures faster, and requires fewer people. Lyons Industries' future is very important, partnering with Massivit. We believe that's the game changer. We believe this relationship is going to take us to another level that we could only dream about.
So another type of mold is, two-part rim mold, a reaction injection molding mold. If you're doing foam for your seat cover, for seats, certainly the boat has requirements for that, for comfort. And you can use this exact same process to create the mold for those for your seats. And so you've got the dual component A and B. You've got Sim 500, which is an A and B mix, and then you've got the water breakable material. That sacrificial shell, one thing I'll note, you noticed it would print a few layers, and then it would then come in and cast, print a few layers, come in and cast. The reason for doing that is twofold. So one of them is that it allows, it makes sure that the exotherm doesn't blow the mold, blow the shell from the heat generated by the casting process. But it also allows it some open time for the cross-linking to take place that allows for it to become isotropic in nature. If you're familiar with traditional 3D printing, you know that all you're doing is heating and cooling different layers. So while you've got a great bond on the X and Y axes, you have a less strong connection at the Z height. And so if the mold were to break, it's going to break off essentially at one of the layer lines. If you were to take a hammer and break a mold for us, it's just going to break in no particular order. It's just going to break organically. So another application is to actually have what we call sacrificial core. Let's say you have mandrels that you want to create. Here, you do not have to do the casting process. You can take the water breakable material, and you can run it and print it, and then all you have to do is a layup process on the sacrificial water breakable material, put it in a bath of water, have it break away, and now you have a finished part. You can do that with complex shapes like air ducts, something that would be very difficult to do in any other process.
IIMS Baltimore conference.
And this just gives you an idea. You have the sacrificial piece, you do the layup around it, put it in a vacuum bag, and you've got your part. Here's another example of a complex shape, a gas tank on a motorcycle. So here it was printed, wrapped with carbon fiber, laid up with carbon fiber, and then placed in water, and the hole where you put in the gas, all of your flakes come out, and you're left with that. A carbon fiber gas tank. And here also in this one piece gives you the other technology. So the seat was done as a rim mold. So you created the two-part A and B mold, and then put the foam in between and created your motorbike seat. Traditional mold, an RTM mold for the back panel, and then what I talked about before, 2 printers in one. So you can also, everything that Jürgen showed you at the beginning, you can also do that with this printer. So this frame, the motorcycle frame here, was actually printed with GDP only, and in the 10,000. So it is you have the GDP printer and you have the mold making printer all in one piece. And you can look at the time to print these: 24 hours for the frame, 10 hours for the rim mold, 6 hours for the RTM mold, and 9 hours for the fuel tank. Fractions of the time. And the most expensive one is 15 kilos. So it's going to end up being a little over $1,000 to print the finished piece. A third application you can use, if you want to create the mold in a more traditional fashion and just use it to make plugs, you can do that. You create the plug, and you use that to actually make your final mold. So you cut out the time to do the plug. But of course, you can also just go straight to the mold. But it's an application if you so choose to do it. Because you have the GDP capability, you can do, this is the slide from Jürgen, all of the things that he had on his slide, you can do with the 10,000. So you can do both. So essentially, as from a summary perspective, you've got all of these different capabilities that you can do, from isotropic molds to jigs and fixtures to in-use parts to prototypes, custom manufacturing, and mandrels. All of that leads to a very, very unique value proposition. A lot of times what you'll get is you might get a savings in time or a savings in labor. And with us, it's really the perfect storm, if you will, across all of those things that make a business profitable. We cut the time dramatically. We cut the labor dramatically. Both of those obviously result in a dramatic reduction in costs as well. We've been blessed to, because of the innovation since the 10,000 was introduced last year, we won the IBEX award, which of course was the innovation award. IBEX is coming up here again in October, and it's one of our pride for what's been done with the 10,000. CAMX, the composites, the largest composites trade show, we won right when in October when the 10,000 was first introduced. It won the ACE Award for Composites Excellence. And then in the UK, we won the TCT Hardware Award. So we've been very fortunate and very proud of the success that the printer has had. These are some of the companies who are benefiting from utilizing Massivit technology, and some very notable names, of course. And we're very proud of that. And we hope to add to that list from maybe some of the companies that are represented within IMS. So what we've got here, we're going to open it up to some Q&A, and we'll turn our cameras on so Bharath will join us. So if there are any more technical questions you have here, I'll leave this slide up as we're talking. It has the contact information for Cindy, who will be on, and she will route any leads to the appropriate individual. I also have the information for Cindy's counterpart in EMEA, has responsibility for the UK as well, of course, out of Brussels. Gaspar, my counterpart, leads that region, as I mentioned earlier. And then I've got our contact in Israel. If for whatever reason you need to contact our corporate headquarters out of Israel. With that, we'll open it up for Q&A. I will stop. Actually, I will just turn my camera on. I just have to figure out where I can do that without stopping sharing.
Nice to know other people have problems with Zoom.
Yes. Well, what I would do is, there we go.
You got it. Right on the bottom. There'll be a line through your camera. You just need to.
Yeah, there we go. All right.
Okay. Brilliant. Thank you, guys. Questions?
Questions?
Any questions? Yeah. Okay.
What's one of the units that like the 10,000 cost for a company to buy it, put it into production? And then what cost benefit analysis?
You probably didn't hear that, did you, online?
Something about cost, of course. He said a cost benefit analysis. I'll from what I think I heard is how we help with the cost benefit analysis. How much does the printer cost? And then for someone to figure it out. So two things. The printer costs, well, depending on what part of the country, it's 795,000. If you got there's the you can buy the 10,000 only, 695,000 pounds or euro, and then if you do the 10,000 G, it's 795,000 dollars, pounds, or euro, and then what we will do is you try to figure out the cost effectiveness. You can provide us with a CAD drawing of a part that you already know how much it costs you to produce. And we will take that and then provide a time and material study in terms of how long it will take to print, as well as the amount of material that will be used, so that you can calculate the cost of that printing process as well. And then you can make that comparison based on the number of parts that you create or the number of molds that you create, and very quickly come to an answer to whether it makes sense for you.
All right, thank you.
Thank you very much.
Bet.
Any other questions?
Maintenance contracts?
Maintenance contracts, somebody has said.
So the printer comes with a year warranty. And then if you want to extend that warranty, we offer an annual essentially extended warranty maintenance contract that it basically extends that for another year or multiple years, whatever your choice or capability might be.
Cost of that?
And the cost of that?
It's basically about 10% of the printer cost.
Yeah.
Any other questions? Any questions from the online guys? You've stunned them all into silence, Kevin.
Yeah.
Well, either we did a great job of answering everything as we went through the presentation.
It's fascinating that the world is changing all around us. This is just isn't it?
Absolutely it is. Absolutely it is.
There's a question in the chat below.
Yes. So Christopher says, what is the gel used?
What is the gel used? What do you mean? I don't understand that question.
Can you expand on that?
What is the gel? What gel does the printer use?
Oh, so Jurgen kind of went through the different types. They're all a photopolymer. So in the case of the GDP portion, there is what we call a multi-purpose gel. It's gray in color, and it's the least expensive because it can't be illuminated. It doesn't have any special fire retardancy. It has fire retardancy capability, but not what we call, in the case of UL Underwriters Laboratories, UL V0 rated material. We have a fire retardant, a special fire retardant material. We have an ABS-like harder material, and then we have a white material that customers, because it's hollow, they often use it to illuminate objects, whether that's channel letters or whether it's statues or special customized pieces. So all of those are photopolymer gels with different characteristics and of course different costs. In the case of the 10,000, we've got the casting material, which is the WB material, the water breakable material, and then we have the epoxy which is the SIM 500 material.
Okay. Any more? No, guys, thank you ever so much. Just going to stop the recording here.